Well, thank you for coming and attending my presentation. I guess I've just been introduced to you as James Roper. I work for Lightbend. Some of you have been saying you're the guy that works on Play Framework, and I did work on Play Framework. I was the tech lead for a number of years, but for the past year and a bit, I've now been working full-time on Lagom, and so, which my t-shirt shows. Today we're going to look at converting monoliths to microservices, and specifically reactive microservices. So we're going to identify some of the pitfalls of doing this. We're going to architect some reactive solutions to these pitfalls. We're going to see Lagom in action. Now, I should say that this presentation is not a presentation about Lagom itself. I'm the lead developer of Lagom. Of course, I'm going to choose Lagom to demonstrate microservices, but the concepts that I'm talking about today will apply to anything. And we're going to see some live coding and some demos, so hopefully you'll enjoy it. So today we're going to see an application called Logon Option. So it's an eBay clone. Who here has heard of or uses eBay? Is eBay used at all in Japan? I can see a few hands sort of going up. So it's an auction website. It allows users to list items on the website and to then bid on them. So this application I originally wrote as a monolith to just get it out really quickly, but then I went to a conference and I heard that microservices were really good, and so I decided to switch it to microservices. And because I've switched it to microservices, it's now going to overtake eBay one day. So why don't we just have a demo of this application. So you can see it here. I actually wrote it with Japanese, I think. So I can create an item. I'm going to auction off my bike. It's a nice bike, people should buy it. We'll go with all the defaults. This auction is going to go for 30 seconds. So I've now created the item, and now I'm going to click I'm happy with it, so I'll start the auction. So then, very secure security, you just select the user from the top here. I log in as Mary, and I can bid, let's bid 5,000 yen. Now the minimum for the bid is 50 yen. Now I'm going to log in as John, and John's going to bid 500 yen, which is accepted, but then it's automatically outbid by Mary because she bid 5,000 yen, and so he's going to bid 1,000. And actually the auction is already over because it was only going to go for 30 seconds, and we can see here that the winning bid was for 550 yen. So that's what we've got in the auction so far. So and it's all happy. It's using microservices. It's using Lagom. And this is basically what the application looked like. So initially I had a monolith, and it used the MVC pattern. So we can see here we had some controllers. The user would make requests. Then that would go and make calls to the item model and to the bidding model, and everything was all happy. It was using Spring, let's say. And then when I'd converted to microservices, I got rid of the monolith, and then I converted all these kind of components to services. So there was a web gateway and an item service and a bidding service, and then to communicate between them, I used REST. So you can go and get an item and get the bid history, and that will return the page. So what happens if something goes wrong? So with microservices means more moving parts. Instead of one application that we're maintaining, we've got many little applications that we're maintaining. And this means that there's more chance for things to go wrong, more chance for things to fail. It also means that there's more chance for things to be inconsistent, because we can't just rely on the fact that it's just one service that's controlling everything. Things can be inconsistent. So a big thing that you may have noticed in my architecture is that I was using synchronous communication. So the word synchronous means existing or occurring at the same time. And when applied to communication, that means that both parties have to be kind of participating in the communication at the same time for it to be successful. So usually it's request-response. So I make a request on this service, it has to be there, and it has to be there at the same time and make a response. And I have to still be around to receive that response. And REST is typically or over HTTP is typically a synchronous protocol. So what happens if the item service goes down? Or let's say it doesn't go down. Let's just say it becomes slow, the bid service. Now, because the bidding service, the web gateway is depending on that and making it using synchronous communication to talk to it, that means if the bidding service is slow, the web gateway will be slow too, even though the item service is still fast. And this means that the user is not going to be happy. So let's have a demonstration of this. So I'm going to simulate high delay on my bidding service by inserting a delay of 30 seconds. So let's just say it suddenly became really popular. Everybody really liked my bike and wants to buy my bike, and they're all hidden there. It's getting to the end of the auction and they're hitting refresh, 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 and it just becomes choked up. And so it's now taking 30 seconds to respond. So if we then go to the auction and we hit refresh, we can see it's really slow. It's just sitting there spinning and nothing's happening. So the user's not going to be very happy about this. So the first thing we can do to ensure that our services are more resilient is to use circuit breakers. So what a circuit breaker is it's a gate that opens when there's a failure. So it basically blocks the communication. It will also include timeouts, so it's got a maximum amount of time that it'll allow things to happen, and if these things start taking longer than that, then it will open. And the idea is that it's meant to protect against already failing services. So the bidding service is already slow, so the circuit breaker is going to help protect it by not allowing any more requests through, and this will give that service a chance to recover. So we put in our circuit breaker and it breaks the circuit, and I'm going to do that now in my application. So it just so happens that Lagom out of the box uses circuit breakers, it's just that I've disabled them. So I'll enable it, and it's got a timeout of 5 seconds. So now if I hit refresh and we wait 5 seconds, we see it failed because the circuit breaker timed out. And I've got it set to a threshold of 2 failures before the gate opens. So we do another request, and now when we start hitting refresh, we get this error saying that it's now open and failing fast. So now the requests are not going to the bidding service at all, instead they're being blocked. Of course, this is not really a solution to anything. Okay? Our web gateway is essentially just blown up and the user is still not happy. So the second pattern that I'm going to introduce is failure recovery. So the idea is that we work around failure by degrading. So still offering some level of service, but not necessarily the full level of service. And in this case, not every call is needed. We don't necessarily need the full history of bids just to render the bidding page, the item page. So the idea is, now that our circuit breaker is open, we're just going to do something else instead so that the web gateway stays happy. So let's have a look. So this is the thing in my web gateway that's making the call on the bid service. It calls get bids. This is Lagom code. You define a service descriptor where you can define these interfaces and then invoke it. So I'm going to add some code here to say to recover from the failure. And so if there is a failure, then I'm going to simply return nil as the list of, as the bidding history. So let's have a look at what happens now. So initially still, it takes 5 seconds to load. In fact, it takes longer because it's recompiling. But now we see the page. Of course, there's no bid history there. And the second call will also take 5 seconds. But once the circuit breaker is open, I can hit refresh and it comes back very quickly and we've got no bidding history. We also have a price of 0. Before it was 550 yen. We'll come back to how to address that. Okay, so we've now seen how we can degrade, how we can protect our services when they're failing and degrade when things are not good. We're now going to look at something that's much worse, and that's inconsistency. So we saw before when you create an item, you can then start an auction. So the way I've implemented this currently is the web gateway posts to the item service, start the auction. And then the item service has to tell the bidding service to start the auction. But what happens if at the time that the item service tells the bidding service to start the auction, the bidding service isn't there, it's crashed? Well, the item service is left going, well, what do? I don't know. And then later on, a user will come and they'll make a bid. The bidding service will be fixed, and a user will make a bid, and it'll say, well, hang on, I don't know about this auction. Nobody ever told me about this auction, and return a 404 back to the user. And so the user won't be happy. So let's see this in action. What we'll do first is we'll get rid of that delay in our bidding service, and we're going to enable this kill flag to kill our bidding service. And then we can go back to the auction. We'll create a new item. I'll set a timeout of 30 minutes for this one. And then we create it, and now we're going to start the auction and see what happens. And of course, that fails because the auction service the bidding service was down, and so threw this exception. And so we then go back, but we see it's actually reporting as started. And then Mary comes and tries to make a bid. And, well, of course, that's not going to work because the bidding service is still down. But I come and I find, oh, I left kill equals true in there. I better fix that, deploy a new version of the software. Bidding service is now running again. And now we bid. And we get this weird error. It's not just weird because it's Japanese and I can't read Japanese. It says, I'm guessing it says, the auction hasn't been started yet. But then here it says the auction was started 42 seconds ago. How can it both be started and not started at the same time? Well, it's an inconsistency. The item service says it's started, the bidding service says it's not started. So the problem here is that we use synchronous, remember, at the same time, communication of updates between our services. In a traditional monolith, the way you handle this is by using transactions. So if you're updating two tables at the same time, you use a transaction and it ensures that both tables are either both updated or not updated. But you don't want transactions spanning service boundaries because then they're not isolated from each other. So the third pattern we're going to look at is asynchronous messaging. So with asynchronous messaging, unlike synchronous, which requires both systems to be participating at the same time, asynchronous messaging means both systems don't need to be participating at the same time. It's perfect if you already persist events. So, because then you can use those persistent events as a source of messages. And in Lagom, the persistence API that we offer is an event sourcing API. So rather than simply storing the current state, so we've got this auction that started, we store the events. Somebody created an auction, somebody started the auction. They're two events. So now when I start the auction, I'm going to get rid of that synchronous call to the bidding service and replace it with an asynchronous call to say that the auction has been started. And so then if the bidding service isn't running at the time, item service doesn't care because it's not using synchronous communication that requires the bidding service to be up. And so then later when the bidding service is fixed, it can handle that call and service the user's request. So let's have a look. At what this looks like. So here's my item service. Now in Lagom you have service descriptors. So we'll go and have a look. And we're declaring that the item service publishes a topic of item events. So I'm going to go and implement this now. At the moment it's just returning an empty source. So I mentioned that Lagom uses event sourcing. Here we're getting the stream of events out of Lagom. So we're going to publish a stream of events and it's going to start from a particular offset. The offsets are used to track which events have been published so far and which haven't, so that when the service goes down and then restarts, we don't publish all the events from the beginning of time again. So having got that event stream, I'm then going to only publish a subset of them. I don't necessarily want to publish all my events. And so I'm matching here on an auction started event. You can see the auction started there. And in this case, I actually need a bit more information. So I'm going to go and ask the entity to get the item. And then I'll convert that item to an auction started event that's part from my API, which will then be published. And in this case, Lagom uses Kafka to publish events between services, so this event, auction started event, is going to be published to Kafka. Now on the bidding service, I've already created this class for subscribing to events. So here's that. I then invoke the item events topic on the item service, and I want to subscribe to it. I want to subscribe to it at least once because I don't want to miss messages. And then this is using Akka streams to handle the events, so I want to handle each one with a map async. And I'm only interested in handling the auction started events. Other events I'll just say that I'm done. And I create an auction and tell the bidding persistent entity to start the auction. So now if we go back here, we'll hit refresh, make sure that it's happy and running. So as Mary, I'm going to place a bid. And this time it worked. But that's interesting because before we tried to start the auction, we didn't create a new auction to try and make sure that it worked this time. This is the old auction that was already broken. So what's actually happened is after implementing this publishing of events, my system has actually recovered from not just is able to handle new failures, but has recovered from old failures. And so this is an example of why not just asynchronous communication between services is great, but because I have this event log of everything that's happened rather than just storing the current state, I can go back in time and fix up things and handle things, which is exactly what's happened here. So before we saw when we fixed our auction service so it was able to degrade from when the bidding service was down and in viewing events, we saw that we had an empty bid history, and there's not much you can do about it. If the bid service is down, you're not going to be able to show the bid history. That's just life. But we also saw that price was zero, not $0, 0 yen, but... and maybe this is a bit of a problem, because you can imagine an auction. Justin Bieber is auctioning off his sunglasses, and it's getting to the end of the auction, and 20 million people are hitting refresh, refresh, refresh. They want to see if the price is updated so they can know if they're going to bid or not. And what they really can is not about the bidding history, but about what the current price is. And so maybe they're happy to tolerate no history, but not the wrong price. So we can see here, this is our situation before the web gateway is happy, but it's returned price $0 to the user, and the user's like, how can this be $0? The auction was you know, it was at 500 yen before. How can it have gone down? So to deal with this, I'm going to introduce a fourth pattern, which is denormalization. So you're probably, if you've ever used a relational database before, you're probably familiar with normalization. And one of the key points with normalization is that you don't duplicate data. Everything has every piece of data is only stored once. Well, with denormalization, we start with a normalized structure, but then we push important information to other services. So, for example, important for system functions, important for business functions, which is in this case, we want to show the user what the price is if we're going to return them the item. And then we store duplicated information in those services. And so this duplication of information is denormalization. It's important to note that this is not about throwing normalization out the window. This is about starting with a normalized view, and then on a case-by-case basis where things are not, where you need increased scalability or increased resilience, take away that normalization in order to improve your system. So, when somebody posts a bid, we're now going to send a price updated message asynchronously from the bidding service to the item service. And so that means when the bid service goes down, the item service is still able to return a price to the user, and so the user is happy. And so let's go and have a look at that. So we'll go back here and we'll kill our bidding service. And then, just as with the item service, we published a stream of events, with the bid service, we're also going to publish a stream of events. So we get the event stream from for the bid service. And again, we're going to collect certain ones of them to publish. In this case, we're actually going to publish two methods. I'm going to kill two birds with one stone here. When a bid is placed, we're going to publish that event, and when the bidding is finished, we're also going to publish that. And so here we create the message for our API and then return it. And with the bidding service, with the bidding finished, there's a little bit more to do, but we won't worry too much about what that is that we're doing. We'll just do it. And then in the item service, we then subscribe to events from the bidding service. So once again, we have our bidding service here, and we invoke that bid events method that we just implemented. We subscribe to it. We're going to handle the messages at least once. And we're going to map them. We'll handle the bidding finished method and the bid placed method to update the price. And so now back in our service, we hit refresh, wait for it to reload. So we can see here that we've got no bid history because we killed the bidding service again, but at least we still have a price, I think. Actually, we don't, because we need to enable the bidding service to actually publish that price. So let's try and do that. So we'll start our bidding service again. So we'll now, log in as me, place a bid. And so we can see the current price is 1,050 yen and the bidding history. Now we kill our service. And the bidding history is gone, but at least we've got the current price, so users aren't going to be like, this is crazy, how can it go gone back down to 0? So, what have we learnt today? We've learnt that moving from a monolith to microservices is not just a matter of replacing, for example, our Spring components or whatever framework you're using with services. It requires re-architecting the way that data flows through your system. We've learnt that failure and inconsistency are the big things that need to be managed. We need to know how failure is going to impact that and ensure that failure does not lead to inconsistency. And so to do that, we've learnt 3 patterns. First of all, we've learned about circuit breakers. Okay, this is going to just help our system be more resilient in general. We've also learnt about failure degradation. So this is going to ensure that when our system does fail, it's not going to cause, when one part of our system fails, it's not going to cause the rest of the system to not function. We've learned about using asynchronous messaging, and this ensures that even in the face of failure, when you have a failure during an update, things can still eventually sort themselves out. And finally, we've learned about how to use denormalization to ensure that the degradation impacts are limited. So, the next steps are you can check out Lagom, www.lagomframework.com. We actually released, so we initially released a Java API. We released the Scala API just 2 days ago, Lagom 1.3.0. And you can, if you're interested, you can also check out this presentation itself at that GitHub URL there. All the source code for the presentation is in there, both in the initial state and the completed state. Thank you, and do we have any questions?
はい、それでは質問何かある方いらっしゃったらよろしくお願いします。2階席の方でもし質問のある方いらっしゃったら恐れ入りますが1階のにマイクが必要となりますので移動お願いします。大丈夫そうですか？何かせっかくの機会なのでまだ少しお時間もありますし、じゃあどうぞ。
Thank you for your talk. And for Scala users, what is the motivation to use Lagom instead of Akka?
Okay, so the question, so with the point of Lagom is to provide guide rails in how to develop microservices. Those guide rails are probably most useful when you know the least about microservices and the least about things like Akka. So it's not going to be as useful as it would be if you were coming from a JEE background with Java and things like that. If you are a Scala developer who's just new to Scala, then it will be very helpful. That said, the APIs that Akka offers, as everybody knows, they tend to be quite untyped. So you've got to know exactly how to do things, and even if you know how to use, for example, Akka persistence, there's still a lot of room for making errors. There's still very easy to get which messages you're supposed to handle at which times, right or wrong. So Lagom provides APIs and test kits that ensure that you get everything right. And so you get these strongly typed APIs. I didn't show the persistence API, but the persistence API is strongly typed, and so it's very useful for that. We've got a service API that again is strongly typed and ensures that both ends of both the client and the server are both agreeing on how to communicate with each other. And it simplifies things greatly. You get the hot reloads, so the development environment, it will run all your services for you with automatically reloading them. You saw all I had to do was edit the code and the system worked.
はい、ありがとうございます。
We've got a question up there. Yeah.
大丈夫です。
Thank you for great talk. I want to know that a relationship between Play framework and this Lagom and also want to know about future of Lagom such as roadmap.
Yeah.
Yeah.
Okay, so first to address the difference between Play framework and Lagom. Play framework is very much a web framework. So this, actually the item controller that you saw that I was using there was a Play controller in a Play action. So Lagom is not designed for handling web at all. It can handle REST requests. It can, to some extent, handle REST requests coming in from the internet, but if you really want to do web, then Play's the thing to go to, and Play integrates very nicely with Lagom. So if you have a web front end to a Lagom system, Play is a very good choice. Lagom's also built on top of Play framework, so there's something to use. And in fact, you can drop down to the Play APIs at any time, and if you need something that Lagom doesn't offer. So the roadmap for Lagom. We are going to be implementing Swagger support in the next major release as one of the features. So at the moment, the easiest way to integrate to Lagom services is to have a binary dependency between them. And in some cases that's fine, in other cases you don't want binary dependencies between your services. So Swagger support allows us to get rid of that because it'll be generated from a Swagger spec. We also provide an improved experience for configuring TLS, and the future, it's still very much dependent on the feedback that we get and what people are saying that they really want to see from Lagom. So possibilities include alternative underlying transports, and yeah, just improving the APIs in general. Cool.
Oh, very good answer. Thank you very much.
ありがとうございます。それではあと1点ぐらいまだ質問のお時間ありますが、どうでしょう。よろしかったですかね。はい、では最後また皆さん拍手よろしくお願いします。Thank you very much.